volume calculation is going to be a little bit easier. So let's talk through that one first. Okay, so if we set up our volume equation for this solid, okay, we're dealing with a pyramid, so the volume equation itself is going to be what? 1/3 capital B, capital H, where B is the area of the base. Our base is a regular hexagon, so what's the area formula going to be for that? 1/2 SAN, okay, times our capital H. So here's our generic formula for this. We can simply plug in all the measures that we know. The length of each side is 6. The apothem measure of our base, we don't know that yet, so I'll leave a space for that. The number of sides, it's a hexagon, so that's also 6. And then the height of our solid itself was given as 10. So all we need to do is we need to take our base, which again is a regular polygon, a regular hexagon, and we need to find, if we take this reference triangle right here, what is the altitude of this reference triangle. So here is the measure that we're looking for. That's the one unknown piece. Okay, so what we can do is take the fact that in a regular hexagon, our reference triangle is specifically what type of triangle. Okay, so it's equilateral, which when we cut in half becomes a 30, 60, 90. Good. Okay, so this angle is 30 degrees, this angle is 60 degrees. And so if we look at this whole right triangle now, this altitude is going to bisect the base, which was 6. So this measure is 3. What does that mean that this altitude, the side, the leg opposite 60 degrees, is going to be? Good. Okay, and so that's our apothem measure, which we can now just calculate through. So 3 times 2 is 6 in the denominator, cancels with this 6. We have 3 times 6, which is 18, times 10, which is 180, times root 3. Our units are centimeters. It's a volume, so that's a 3-dimensional measurement, so we're going to cube that, and we get our measure for the volume. All right, so that one's straightforward. Again, you can convert it into decimals if you need to. All right. The surface area is a little more challenging. Okay, although the equation for this is real straightforward. It's just the sum of all the faces of this solid. So we're going to take our base, there's only one of them, and to that we're going to add all the triangular lateral faces, and all of those faces are exactly the same because the base is a regular polygon. So we can take 6 of these triangles and add it to our base. Okay, so again, if we're looking for generic formulas on this, our base has a formula of 1/2 SAN, which is right here. We already see the actual numbers for it, so we can just copy those over. I'll put it in the generic form first, so 1/2 SAN. And then to that we're going to add 6 times the area of the triangle, 1/2 base times height. Okay, so if we put in the values that we know, again it's just copying these. The side length is 6, the apothem measure is 3 root 3, the number of sides is 6, and we're going to add 6 times 1/2. Now we look at just one of these lateral faces, these triangles, and we want to find its area. So the base of that was given as 6. And so all we need is one more measure, and that's this height. So the last piece of information we need in order to solve this is the height of this lateral face. So here's the measure that we're looking for. Right. In order for us to find that, you do need to create a right triangle inside your figure. So if we move from the vertex of our solid down to the center of our base, which we know is a length of 10, that's the height of our solid. And then we connect that to the midpoint of this side. Do we know what this length is right here from the center of the regular polygon all the way to the midpoint of its side? Yeah, it's just that apothem measure. It's 3 root 3. So we could substitute that in. And now our h value, we have one missing side of a right triangle. So anytime you have 2 sides of a right triangle and you need to find the third side, and don't think of trig ratios or law of sines, law of cosines. Think more simply, and it's just the Pythagorean theorem. Okay? So we can use Pythagorean theorem to solve for h. The hypotenuse squared, h squared, is equal to the sum of the squares of the other two sides. So 3 root 3 squared plus 10 squared. Therefore, that's equal to 3 squared is 9, root 3 squared is 3, 9 times 3 is 27, plus 10 squared is 100. So we get h squared is equal to 127. Extract the square root. You get h is equal to plus or minus root 127. We can disregard the negative of that because it's a measure, a length. So we have square root of 127. We can't simplify that any further. And so when we go through to solve this, half of 6 is 3. 3 times 3 is 9. Times 6 is 54. Root 3. Plus, again, half of 6 is 3. 3 times 6 is 18. Root 127. So there's our measure. It's in terms of centimeters. It's an area, so it's a two-dimensional measurement, so we'll square it. And that gives us our overall answer.